Okay, so the last section of this chapter is going to help us so we're not just randomly guessing zeros. So what's bad about having to guess zeros, right? Well, there's some things I can think of. It's hard to just randomly guess a number. If the zero is at like negative 400, how am I ever going to guess that, right? Also, what if it's a fraction or something like that, right? Like it's not the best idea. There's got to be a better way, and there is. And it's something called the rational zero theorem. And this gives you a list of possible rational zeros. And so what we're going to call these, and what everyone calls these, possible rational zeros, we call these PRZs. Oh my gosh, why does my computer hate me? And that will give you possible zeros that you can guess and check instead of just randomly guessing every number. And it'll also give you some fractions, okay? So it says, and I know it's kind of wordy, but it says if a polynomial function with integral coefficients, that means integers, then every rational zero, so every time that you're going to get a zero, is in the form of p over q, a rational number where p is a factor of the constant term and q is the factor of the leading coefficient. So look at this, all right? So list all possible rational zeros. So you need to write this down. To find PRZs, you're going to take factors of the constant term over factors of the leading coefficient. So the constant is the one that doesn't have a letter in it, right? It's usually the last one. So we're going to take factors of 2, and we're going to divide that by factors of the leading coefficient, which remember is the highest degree and the number in front of that, usually the first one if it's written in order, over factors of 15. So if I was going to list these out here, factors of 2, well, 2 is a prime number, so it's just 1 and 2. But think about the signs on that. Like, couldn't it be negative 1 and positive 2? Sorry, negative 1. Oh, yeah, factors of negative 2. I guess I should pay attention to that. Negative 1 times 2 would give me 2, but also negative 2 times positive 1. So you can always change the signs. So we're just going to say plus or minus. So we're going to say plus or minus 1 and plus or minus 2. Those are factors of 2. And factors of 15 are plus or minus 1, plus or minus 3, plus or minus 5, plus or minus 15, right? Factors are things that divide into 15 evenly. And if I was going to list all those out, I have to list out 1 over all of these numbers. So 1 over 1 is just plus or minus 1. But 1 over 3 is plus or minus 1/3. 1 over 5 is plus or minus 1/5. And 1 over 15 is plus or minus 1/15. And then I also have to put 2 over each of those. So that would be plus or minus 2. 2 over 1 is 2. 2 over 3 is plus or minus 2/3. 2 over 5 is plus or minus 2/5. And 2 over 15 is plus or minus 2 over 15. Now I know that that's gross numbers, but instead of an infinite amount of zeros, you now have a list of numbers that you could check to see if they work. So let's try one that's not so ugly, okay? So we're not solving anything here. We're just listing our PRZs. So again, PRZs, it's factors of the constant on the top. So in this case, it's negative 15. So I'm just going to list them, all right? So I'm going to do 1. I always do it from least to greatest, but you could put like 1 and 15 together and 3 and 5 together. It doesn't matter. But I just always go from 1 up to 15. And oh my gosh, this is the best one, right? Over factors of the leading coefficient, and the leading coefficient is just 1. So this is what you hope is on your test, right? This means we don't have to have any fractions because all of these over 1 are just plus or minus 1, plus or minus 3, plus or minus 5, plus or minus 15. So there's really 8 numbers that we would have to check. But again, 8 out of infinite many is a pretty good thing to do. So on your test, you're definitely going to have some questions that I just ask you to list the PRZs. So now, putting it all together, I can ask you to find the zero. So notice this one, again, directions are important. It says find all rational zeros, which means they don't want irrational and they don't want imaginary. So you have to know what that means. It means if you can't factor it out, then it's not an answer that they want. They just want rational zeros. So what am I going to do? Step one, I'm going to find my PRZs. Just like the last one, man, I jump out and I notice that when the leading coefficient's 1. So this one's just going to be factors of 21 over factors of 1. So I'm not even going to put a fraction on this because when I'm dividing by 1, I'm not going to have a fraction. So factors of 21 are 1 and 3 and 7 and 21. And you could just start guessing there. You also could do your Descartes rule of signs to try to help, maybe to know whether to start with the positives or the negatives. There's only 8 here, so it's not that bad, but I'm just going to do Descartes rule of signs just to remind you. Plus, plus, minus, plus. That changes 2 times, so I know that there are 2 real, positive real roots. And if I did the negative ones, that would change that x to the third to a negative. This would be a positive, and a positive. And I get that there's 1 negative real root. So I'm going to start with the negative based on this, but just know that it might not be rational, and so don't let that trick you. And this is where you might decide you hate Descartes' rule of signs because of it, but I'm going to try the negative. So I'm going to start, and I'm going to choose -1 first. And maybe you have a feeling you choose -7 first. I don't know. I just always start with -1 and hope that it works. So that would give me -1 plus 3 plus 25 plus 21. That definitely did not work, did it? I'm doubting that this is going to have a -1 that works now. But that's all right. I'm going to get my calculator now, and this is where you have to just type the numbers in. So give me a second so I can be prepared here. So I would get -3 to the third plus 3 times -3 squared minus 25 times -3 plus 21. And I got 96. So this seems like it's getting bigger to me, not smaller. So I'm feeling a little hopeless, but I'm going to keep going. The nice thing is once you type it in your calculator once, or at least my calculators, I can just go back and change that -3 to a -7. And again, it's really nice if you have a calculator right now that you're checking that with. Oh, look, I didn't give up, and that's good. Because when I typed in -7, I got 0. Now, I could just keep checking. There's 8 of them here. These are the only possible rational zeros. So you could check all 8, but I hate doing that. So what I'm going to do is just like we did yesterday, I'm going to divide that out. So if -7 is a 0, I know x equals -7 is one answer. I'm going to divide that out now. So I have a 1, a 3, a -25, and a 21. So I get -7. That's -4, that's 28, that's -21, so I get 0. Since these directions say only the rational zeros, I'm going to take what's left here, so 1x squared minus 4x plus 3, and if that's factorable, I should be able to find some more rational zeros. If it's not factorable, or if you do the quadratic formula and it's a square root, I don't want it, all right? So what multiplies to give me 3 that adds to give me -4? Well, that's just -3 and -1. So if I solve that, I get x equals 3 and x equals 1. And I also have my answer of x equals -7. So this one actually had 3 real rational roots. Okay? Okay. So, let's do 1 to the 4th power. So again, if only asking for rational zeros, you do not have to give anything that's not factorable. So anything imaginary or irrational, you don't have to do. Okay, yeah, so this is it. So we've not done 1 to the 4th power, but the 4th power, you have to do a little bit more work. So again, step one, I like Descartes' rule of signs, so I'm going to start with that. Plus, 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 plus. Hey, look at that. There are no sign changes, which means I know there are 0 positive real zeros. So I kind of don't even care to do the other ones, but I'll do it. If I did negative here, that would be that would stay the same. That would change. That would stay the same. Change, stay the same. So that's a lot, right? 1, 2, 3, 4. So there are 4 or 2 or 0 negative real zeros, which means there are also 4 or 2 or 0 imaginary. It's really not that important, which is why you don't have to do this whole thing. But this right here is super important to me because when I do my PRZs, I'm going to take factors of 12. So plus or minus 1, there's a lot on 12. Plus or minus 2, plus or minus 3, plus or minus 4, plus or minus 6, and plus or minus 12. And then I'm going to divide that by factors of 2, which are plus or minus 1, and plus or minus 2. So if I list all those out, everything over 1, so that's all the whole numbers, plus or minus 1, plus or minus 2, plus or minus 3, plus or minus 4, plus or minus 6, plus or minus 12. And then I have to put everything over 2, right? So 1 over 2 is plus or minus 1/2. 2 over 2 is 1, so I don't need to list that again. That's the same number. But 3 over 2 is different. 4 over 2 is 2, already listed. 6 divided by 2 is 3, already listed. And 12 divided by 2 is 6, so it's already listed. But still I have 2, 4, 6, 8, 10, 12, 14, 16 numbers with the plus or minus. But the fact that I know there are 0 positive real roots means that I don't have to check any of the positive ones, right? So I'm going to start by checking with the negative ones. Let me put this up here so I can see the number. So I'm going to start by checking -1. And I'm just going to use my calculator because I'm tired, right? So if I check -1, I would get 2 minus 11 plus 26 minus 29 plus 12. Oh, hallelujah. I got 0 when I plugged that in. But here's what I want to show you. What's different about when it's to the 4th power? When I divide this 0 out, when I divide this out, I have 2, 11, 26, 29, and 12. So I have a 2. 2 times -1 is -2. Add that to get 9. -9 and 26 would be 17, right? So that would be -17. And that would be 12, and that would be -12. So normally I give you an x to the 3rd problem, you divide one out and you get x squared. But I gave you an x to the 4th problem, right? This was x to the 4th. So if we write what's left, we're left with 2x cubed plus 9x squared plus 17x plus 12. I still can't do factoring on that, right? Factor by grouping is not going to work on this one. It doesn't fit my other patterns. So this means I have to go back to guessing, right? So I found 1 0 here, but I need to go back and find some more. And you could do your PRZs again, but notice in this one they're going to be the same. So I just have to check some more numbers. And I do want to caution you, the one tricky thing that can happen is remember that you could have a repeated 0. So that means -1 has a chance of working again. It doesn't happen very often, but it could. But I'm gonna skip it and I'm gonna go to -2 and see if I can find it to work. So I got to go back up. Oh, there's my problem. And again, you could go back to the original one, but there's no need to. Use the depressed polynomial. And that's what we call this. Once you divide it out, it's called a depressed polynomial. Maybe you feel depressed after doing this. That's a funny joke, right? All right, so I'm going to plug in -2. 2 times -2 to the 3rd plus 9 times -2 squared plus 17 times -2 plus 12. And I got -2. So that doesn't work. So I'm going to try -3. And this is the worst part. right, is going back and finding those numbers. So I'm just going back and changing my numbers here. And when I plugged in -3, I got -12. So again, it's not looking so good. So maybe I start jumping around. Maybe I pick -1/2 next. So I'm going to go to -1/2. Oh my goodness. This is exciting, right? I should have done this ahead of time and I would know the answer, right? When I plugged in -1/2, I got 5.5. So that didn't work. And so this is the part that probably on your test, I'm not going to give you one that has like 30 ones to check, because obviously I know you have a limited amount of time to do that. So, oh my goodness, I'm struggling. I think it's going to be -3/2. I really do. Sorry, I'm just typing in a lot of things. Yeah, I think -3/2 is what gives me 0 on this. So you might have a fraction every now and again, and maybe you checked all of them, and I don't have a suggestion for you of like what's a better way to do it, except for you just have to check them. So I'm going to now take this and I'm going to divide out -3/2. So I have 2, 9, 17, and 12. And don't freak out. You can do this on your calculator, but when you multiply 2 times -3/2, the 2's are just going to cancel. So that's -3. Then I'm going to get 6. And 6 times -3/2, the 2 would cancel with the 6. And that would just be 3 times -3, which is -9. And then 17 minus 9 is 8, right? And so the 8 and the 2 would cancel out to be a 4 times -3 is -12, which gives me 0. So I divided out, what did I divide out first? -1 and 3/2. So right now I have x equals -1. I have x equals -3/2. And then look what I have left. 2x squared, because I'm going from the third to squared, plus 6x plus 8 equals 0. And since I'm solving this, right, I can divide this whole thing by 2. So that would be x squared plus 3x plus 4. And then if I can factor this, I could factor it if it works out to be rational. But this is not going to work out because I want to multiply to get +4 and add to give 3. And you might think, well, x plus 1 and x plus 4, but that's going to give you not 3 in the middle, right? So this is not factorable, which means this is not pretty, all right? It doesn't factor nicely, so it's not rational. So these are my only 2 rational zeros. And then the only other thing I have to do for you for this chapter is the next lesson is, okay, find all the zeros now, even the ugly, irrational, imaginary ones.